Chapter 3, Quadratic Equation Part 3. In this video, I would like to introduce how to use graphical method to solve the quadratic equations. Before that, let's try to discuss what is the meaning about quadratic graph. If we have an equation like this, y is equal to 3x plus 4, I know if we plot it by maybe using some junior form technique, consider a pair of x and y, you can find this is a straight line, and then we can plot it, and then the equation like this, and this is x and this is y, and then this is y is equal to 3x plus 4. That means the shape of this equation, which is a straight line. If we change the equations from linear to quadratic, this is our quadratic equations. Y is equal to, with the term with x squared, and remember a cannot be equal to 0. If we plot it, what's the shape of the graph? Let's see example 3.9. By computing this table, we can find several pair of x and y coordinates which satisfy this graph. And let's plot it. When x is equal to -2, y is equal to 0, x is equal to -1, y is equal to -2, x is equal to 0, y is also equal to -2, and then we can plot it by using the several points. The shape is like that. And then the equation is y is equal to x squared plus x minus 2. This is the shape of the parabola, which is a parabola. And what is the use of this graph? If we consider the x-intercept of this graph, what's the meaning about x-intercept? That means when y is equal to 0, this is the x-intercept. X-intercept is equal to -2 and 1. I can use this graph to solve when y is equal to 0. So by consider x-intercept on the graph, x-intercept is equal to -2 over 1. So we may make good use of it and then solve this quadratic equations. But what I want to emphasize is that because the graphical method is approximate values, it's not exact values. So in general, I will add 0.0 here to emphasize this answer is approximate values rather than exact values. Let's see another example. Example 3.9.1. If we know the quadratic graph, y is equal to x minus 1 squared, I want to solve this quadratic equations. That means compare these two equations. Y is equal to 0. I can find the point on the graph when y is equal to 0. That means this part, this point. What's the corresponding values of x? So the answer is x is equal to 1.0. Next page. Example 3.10. Given the graph of given a quadratic graph, y is equal to -x squared plus 4x. I want to use the graph to solve the following equations. First is -x squared plus 4x. Can you see they're equal? One thing you need to emphasize is that when y is equal to 0, so find the point on the graph when y is equal to 0, that means this 2 points. Then x is equal to 0.0 or 4.0. How about question B? If I want to use the graph, can you see this time the left hand side, this part is not exactly equal to our equations. So what can we do? Maybe we need to try to simplify it to find what's the corresponding values of y. So I will leave this part on the left hand side. That means make left hand side which is equal to negative x squared plus 4x. So negative x squared plus 4x. I want to remove this negative 5. I need to add 5 on both sides. So how to make good use of the graph? Okay, this is the function y. Y is equal to 5. That means I need to find the point when y is equal to 5. But can you see? Impossible. Because y is equal to 5 is above this graph. So our conclusion is, maybe how can we represent our answer better? Maybe you can draw a straight line here. I need to consider y is equal to 5. No intersection point, so no solutions, no real roots. How about part C? What can we do? If we want to make good use of the graph, maybe I need to simplify or make the left-hand side which is equal to our graph. So, can you see this is x squared, and this is negative x squared, this is minus 4x, this is plus 4x. So, I will multiply negative 1 on both sides. And then now, this is our equations when y is equal to 4. So go back to your figure to find when y is equal to 4, that means these positions, x is equal to 2.0. I just demonstrate how to make good use of the graph to solve the quadratic equations. We will have a deeper discussion during the lesson.